Sumerian tablets are probably one of the oldest form of written record that we have.
Sumerian tablet that actually shows the tree of life.
They created man according to the Sumerian text.
A Sumerian tablet in the British Museum says Earth once had 2 moons, and on a single night in the 11th month, one of them tore itself apart over Mesopotamia and rained fire on 40,000 people. The catalog number is K8538. The coordinates pressed into its clay describe a real, mathematically stable orbit, verified 4,000 years later by an astronomer at Bristol who could not believe what his software was telling him.
It was a huge bang thing like that. It was a very explosive matter.
The second moon existed. It vanished in fragments. And what makes this tablet truly terrifying is not what the scribe wrote down. It is what he wrote down last. The scribe who saw it. He invents a name for it that night. Nam Akuur. The stranger moon, the foreign orb. The word appears nowhere else in the entire cuneiform corpus, before or after, because nobody else ever needed it. The man pressing those marks into clay is a Tupsar Enuma Anu Enlil, scribe of the heavens. He is not a priest. He is not a mystic. He is a trained professional sky watcher in a civilization that built 3 observation towers in this single city, staffed in shifts, watching the sky day and night, the way later cultures watched their borders. His training started when he was a boy. He learned to recognize stars by sight. He learned to calculate planetary positions from mathematical tables older than his grandfather.
Once cuneiform was deciphered, lots of unexpected things came to light.
He learned to measure the sky with his own body. Finger held at arm's length for 1 degree of arc, fist for 10, hand span for 20, crude tools, brutally accurate results. Get the astronomy wrong in Mesopotamia and people starve. Crops fail, floods come without warning, the gods turn their backs. So this scribe, on this night, in the month of Abu, late July by our calendar, reaches for the only kind of certainty he trusts. He measures. The stranger moon is smaller than the regular one, but brighter. It rose in the west tonight, not the east. He notes the time it became visible, the phase of the familiar moon at that exact moment, the stars it appeared between. Then he calculates its angular distance from the regular moon. Then he calculates it again, then a third time. The numbers do not change. The numbers are real. He notes the orbital period, 19 days. Wrong. The regular moon takes 29. He writes it anyway. He writes the conjunction timings, the ecliptic crossing, the bearings. He writes coordinates. He does not know that is what he is doing. He is just refusing to look away. The temple archive at Ur, where his finished tablet will eventually be filed, holds astronomical diaries stretching back more than 400 years. In all that time, in all those generations of scribes pressing observations into clay, no one has ever needed the word he invents tonight. No one has ever had to. The pattern of the heavens is the one thing in Mesopotamian life that has always been reliable. The sky is the bedrock under everything, and tonight the bedrock has cracked.
Writing on clay, again, in a different way to preserve our information now.
He looks down at his fresh tablet by torchlight. He has filled the front side with the night's standard observations, the routine entries for the king's record, moon phases, Venus transits, Jupiter against the fixed stars, the kind of work he could do half asleep. Then on the reverse side, his handwriting changes. It tightens, it slows down. The marks get more careful, more deliberate, as if the clay itself might object to what he is asking it to hold. He repeats his measurements one more time before he commits them. Same numbers, same impossibility. He writes the new word, Nam Akuur. He underlines nothing because cuneiform does not work that way, but he isolates the term with a spacing convention reserved for things that have no precedent. He is telling whoever reads this in the future that he knew this was unprecedented. He is leaving them a flag. In the morning, runners arrive from the next city. The observers there saw it too. The coordinates in Bristol. Skip forward 4,000 years. A man named Dr. Robert Massey is sitting in his office at the Bristol University Observatory, researching ancient eclipse predictions, when a colleague drops a translation of K 8538 onto his desk. Just a printout. A few pages of cuneiform passages rendered into English by a Mesopotamian linguist. The colleague thinks Massey will find the language interesting. That is all. Massey reads the second moon passages. He gets to the angular measurements, and he stops. Here is the thing every historian before him had missed. The numbers were not symbolic. The Sumerians had not been speaking in metaphor when they wrote down the distance between two celestial bodies at 3 different points in their orbits. They were giving coordinates. They were giving them in a system Massey could convert. He fed the data into orbital mechanics software designed to model satellite trajectories. The program runs Newton's laws against the input and tells you whether the numbers describe a real, stable orbit or whether they are noise. It is the same software modern astronomers use to track satellites over your house tonight. Massey did not expect anything. He was running the test the way a chemist runs a control. He thought the numbers would come back as garbage, and he would write a polite paragraph about how interesting Bronze Age symbolism could be, and he would put the printout in a drawer. Then the screen showed him an orbit. Not a guess, not a possibility. A genuine, mathematically coherent lunar trajectory. Retrograde, meaning it moved opposite Earth's rotation. Stable, semi-major axis. Eccentricity that lined up with the brightness pulses described in the text. And when Massey converted the 4,000-year-old measurements into modern astronomical units, they came in accurate to within 2% of what his simulation predicted. 2%, from a man with a finger held to the sky. Massey, by his own later account, sat at his desk for a long time before he called anyone. He ran the simulation again. He fed the data in fresh. He checked the linguist's translation for ambiguity. There was none.
Most of the material that made up our solar system kind of got swept up into the sun and to the individual planets, but not all of it.
He triple-checked the conversion from Sumerian degrees to modern arc seconds. The numbers held. The Sumerians had been right. The math was real. The stranger moon had existed. Massey published in the Journal for the History of Astronomy. His conclusion was one sentence long. Either Bronze Age astronomers had observational and mathematical capabilities far beyond anything we credit them with, or they were recording an actual astronomical event that we have completely overlooked. The academic response was the response you would expect. Ancient astronaut theorists declared victory. Mainstream archaeologists called it a translation error. Everyone had an opinion, nobody had evidence. Then the cross-references started coming in. If you are with me this far, hit subscribe before we go any further, because this is where it stops being a Sumerian story. Every major civilization in the region recorded the same thing in the same year, and what they all saw next is the part most people have never heard. Every civilization saw it. An Akkadian clay prism from the city of Kish, dated to 2093 BCE, mentions 2 shepherds in the night sky, and describes how the younger shepherd appeared suddenly and walked backwards across the stars. Walking backwards across the stars is exactly how a retrograde orbit looks to a naked eye. The Akkadian text adds something the Sumerian tablet does not. The stranger moon pulsed, brighter as it approached, dimmer as it receded. That is the signature of a rotating asteroid with uneven surface reflectivity observed by men who had no concept of reflectivity, no concept of asteroids, just eyes and patience. What makes the Akkadian record valuable is how it cross-checks the Sumerian one. The 2 cities use the same observation network, the same standardized vocabulary, the same measurement systems. Tablets from Kish and tablets from written by different scribes 100 miles apart, share the same terms in the same positions on the clay. When something unusual showed up in the sky, multiple observatories could verify it independently, and they could compare notes the way modern astronomers compare data sets. The stranger moon shows up in both records on the same night, in the same position, with the same orbital description. That is not a shared myth. That is 2 independent measurements of the same physical object. Egyptian temple records from the same window mention an unusual celestial body the priests called the Eye of Set, the god of chaos and destruction. The hieroglyphic dating places its appearance during the reign of Mentuhotep II, which lines up cleanly with the Sumerian timeline. The Egyptians add another piece. The Eye of Set was visible only at certain hours of the night, never at noon, never in daylight. That visibility window matches a retrograde orbit at exactly the distance K 8,538 describes. Egyptian astronomers had no contact with their Sumerian counterparts. Different language, different calendar, different religious framework, and yet the orbital fingerprint they wrote down is the same. In 2015, archaeologists in northern Syria found a row of stone pillars carved with astronomical markers.
What we see now in the asteroid belt are remnants of those catastrophic destructions.
Carbon dating put the construction at 2100 BCE. On one of those pillars, someone had carved a diagram. 2 orbital paths around a central circle representing Earth. One circular and regular, marked with 29 notches. The other elliptical, irregular, marked with 19. A schematic of 2 moons by people who knew exactly what they were looking at. This was not metaphor. This was technical drawing. And here is the catch. The Chinese have it too. The Bamboo Annals, a chronology compiled from older sources, references the year of twin moons during the Xia dynasty. Historians had filed it under mythology for centuries. The account includes a detail that gives the lie to that. During the months of 2 moons, the Yellow River produced double tides. Water levels swung wildly. 2 moons means 2 gravitational pulls on the oceans and rivers. The tides would have been chaotic. The Chinese were not making it up. They were measuring it from the riverbank. So now you have 4 civilizations on 3 different river systems, all writing down the same impossible thing in the same 11-month window. Different scripts, different gods, different reasons to look up. The same answer. The scribe at Ur was not delusional. He was not alone. He was just the first to see what came next. The night the sky wept fire. The scribe is back at his platform in Ur, and the orbits are wrong. It is the 11th month of the stranger moon's appearance. The smaller disk no longer keeps its old path. Each night, it drifts closer to the regular moon. The 2 of them edge toward each other across the heavens, and the city below begins to feel it. Temple priests order extra sacrifices. The king consults diviners. The scribe records emergency meetings in his tower, observers arguing about what is about to happen. Some say the stranger moon will pass. Others say it will collide with the regular moon. Others say something worse. None of them are right. On the night of the 3rd new moon in the year's final month, the stranger flares. It brightens to the intensity of the sun, then it shatters. The scribe writes what he sees in 3 short, controlled passages, like a man trying not to scream into the clay. 1,000 burning stones across the sky. A meteor shower lasting 3 full nights.
Keep their distance very nicely in the asteroid belt between the orbits of Mars and Jupiter.
Fireballs. Impact sounds heard across the entire region. Fires breaking out in city after city as falling debris hit roofs and grain stores and irrigation canals. The Euphrates River boiled in places where the largest fragments hit the water. 16 great fires in Ur alone, the tablet says. Countless dead in the outer villages. Akkadian sources put the total death toll across southern Mesopotamia at over 40,000. 40,000 people. From a thing in the sky that was not supposed to be there. Picture the scribe's view from his tower platform. The horizon to the west is burning. The horizon to the east is burning. Above him, the regular moon is still there, untouched, indifferent. The stranger moon is gone, replaced by a falling rain of light that lasts for 3 nights and breaks the world he has spent his life cataloging. He keeps writing. That is the part that lands hardest when you read the tablet today. The man on the platform does not run. He does not abandon his post. He measures the trajectory of the falling fragments. He counts impact flashes on the southern horizon. He records the time intervals between impact sounds reaching the city. The clay tablet that holds his account is one of the most controlled documents ever produced under that kind of stress, because he kept being a scribe through the worst night of his life. He understood, on some level we will never quite reach, that what he was watching needed to be remembered. Archaeology backs him up, line by line. Excavations at Ur show a sharp break in the material record around 2093 BCE. Buildings abandoned mid-construction. Pottery workshops left with unfinished vessels still on the wheels. Grain stores burned and never rebuilt. King Amar Singh's reign, which had been stable for years, collapsed into refugee movements, crop failures from broken irrigation, and civil unrest. The scribe's city did not recover for a generation. And here is something nobody expected. After the disaster, the surviving sky watchers did not abandon their towers. They doubled down. The number of astronomical diaries from Mesopotamia increases sharply in the years after 2093 BCE, as if the survivors had collectively decided that whatever happened in the sky was never going to catch them off guard again. The same pattern shows up in Egypt. Temple astronomy gets more sophisticated after the Eye of Set vanishes. In China, imperial astronomers receive new funding and elevated status in the years after the Year of Twin Moons. The stranger moon did not just kill people. It changed how every civilization that survived looked at the heavens forever. And the dirt itself remembers. Core samples from the Mesopotamian floodplain show a distinct impact layer.
But some of them over time, because of being tweaked by the gravitational pull of Jupiter and whatnot, have made their way into the inner solar system.
Dated to approximately 2093 BCE. The sediment is full of microscopic spherules, tiny glass beads that only form when rock is hit with extreme heat and pressure at the same time. The chemical signature does not match volcanic activity. It does not match a normal meteorite. It matches something else, something we do not have a clean, modern analog for. The closest comparison researchers have proposed is the Tunguska event of 1908. But Tunguska was a single airburst over an empty Siberian forest. The 2093 BCE layer is broader, denser, and laid down across a region where people lived in cities. The geology is telling the same story the clay tablet is telling. Then there are the craters. Dr. Sarah Parcak, a space archaeologist at the University of Alabama, sat down with satellite imagery of the region and went looking for impact scars from that exact window. In her lab, scrolling through ground-penetrating radar returns, she found 19 of them. 19 circular formations across Iraq and Syria, hidden under 4 millennia of sediment, invisible to anyone walking the ground above them. Most are small, 50 to 200 meters across. 2 are not. One of them, near the ancient city of Sippar, measures over 600 meters in diameter. 19 craters, all dating to the same narrow window, all filled in by time, all exactly where the tablet says they should be. So what fell out of the sky over the scribe's head? A world almost ending. The cleanest answer comes from Dr. Eric Asfaug, a planetary scientist at the University of California. He read the orbital parameters from K 8538, sat with the numbers, and proposed something specific. The stranger moon was a captured asteroid, a rock that wandered too close to Earth, got snared by our gravity, and settled into a temporary orbit it could not hold. He ran the simulation. Different compositions, different sizes, different approach vectors. In every scenario that matched the Sumerian data, the asteroid did the same thing. It orbited stably for about 11 months. Then, it crossed a line called the Roche limit and tore itself apart. Here is the physics in one breath. Every object has a tidal radius, a distance from a larger body where gravity starts pulling harder on the near side of the object than the far side. For rocky bodies, that line sits at about 2.5 Earth radii. For icy bodies, 3.5. Inside that line, the differential pull exceeds the object's structural strength, and the object does not crack, it explodes. Asfaug's reconstruction. An asteroid roughly 800 meters across, probably nickel iron based on the hammered copper description, captured by Earth's gravity during a close approach. 11 months of decaying retrograde orbit, each pass slightly closer. Tidal stress building, microfractures spreading through the interior. Then the Roche limit, at approximately 18,000 kilometers altitude, and the asteroid comes apart in hours. Most of the fragments burn up in the atmosphere. That is the sky that wept fire. But Asfaug estimates 15 to 20% of the original mass made it to the ground. That is what carved Parcak's 19 craters. That is what killed the 40,000. That is what the scribe at watched from his tower. But here is what keeps astronomers awake at night. The Sumerian coordinates show the stranger moon passed within 12,000 miles of Earth on its final orbit. That is, inside the orbit of some satellites circling above your head right now. If the asteroid had been slightly larger, or if its trajectory had been fractionally different, it would not have fragmented, it would have hit intact. Asfaug ran that scenario too. An 800-meter iron asteroid, striking Earth at orbital velocity, releases energy equivalent to 15,000 megatons, 300,000 times the Hiroshima bomb. The crater it carves is 15 kilometers across. Everything within 500 kilometers is incinerated in the first second. The atmospheric shock wave laps the planet. Enough debris is thrown into the upper atmosphere to trigger a multi-year impact winter. Agriculture collapses, mass starvation. The few survivors get thrown back into pre-technological existence. That is not a regional disaster. That is humanity ending. 12,000 miles, the width of a coin held against the sky.
We've only discovered less than 40% of the 90% of the object we need to discover.
The mechanism is still running. So, can it happen again? It already has. In 2006, astronomers spotted a small object designated 2006, RH-120. It orbited Earth for 13 months as a temporary second moon, then drifted off into solar orbit. It was only 5 meters wide, harmless, but it proved something the scribe at Ur could not have known. The mechanism that captured the stranger moon 4,000 years ago is not extinct. It is still running. Earth still catches things, quietly, when nobody is watching. NASA's Near-Earth Object Program tracks over 30,000 asteroids. They have cataloged about 95% of the kilometer-class objects that could end civilization. But the 800-meter class, the size of the stranger moon, sits in a darker zone. We have probably found about 40%. The other 60% are out there, unmapped, on orbits we have not solved. And get this, an 800-meter asteroid does not need to hit the ground to ruin everything. The Chelyabinsk meteor in 2013 was 20 meters across. It exploded 30 kilometers up and still injured over 1,500 people through shockwave damage alone. Scale that to 800 meters of nickel iron breaking up at altitude over a modern city, and the calculation gets ugly fast. Dense populations, fragile infrastructure, buildings that fall when their windows blow inward, highway overpasses that buckle, power grids that go dark across continents, water treatment plants that stop working in the same minute. The Sumerians had no warning before the stranger moon arrived. One night the sky was the sky, the next night it had changed. Modern astronomy would give us more notice, but not much. A week, maybe 2 if we are lucky, and the rock is not coming from the direction of the sun where our telescopes go blind. There is a class of asteroid that orbits inside Earth's orbit, hidden in solar glare for months at a time, and we essentially cannot see them at all until they cross out of the sun's halo and into our night sky. By then, if one is on a collision path, the warning is measured in days. And here is the uncomfortable arithmetic. If an 800-meter object showed up tomorrow on a stable retrograde orbit, like the one the scribe at Ur described, the timeline gives us roughly the same 11 months of observation he had. 11 months is not enough to deflect anything that big. Current planetary defense technology, including the kinetic impactor mission NASA tested in 2022, was designed for objects spotted years in advance, not objects already in Earth orbit. We could watch it. We could measure it. We could write our own version of K, 8,538 inches real time. We could not stop it. The scribe at Ur did not have a week. He had nothing. He had his finger held to the sky and a stylus in his other hand. And what he wrote down 4,000 years ago is now the only direct record of what an event like this looks like from the ground.
Radar is an active form of observing an asteroid in the sense that we generate our own electromagnetic waves.
A scribe's last line. The tablet sits in the British Museum today. Catalog number K, 8,538. You can request to see it if you visit. Most people walk past the case. It looks like every other piece of clay in the collection. Boring, administrative, forgettable. A first-time visitor would not glance at it twice. But that piece of clay is the only object on Earth that carries an eyewitness account of the night humanity almost ended. Pressed into wet mud by a man whose name we will never know, baked hard in a kiln, buried under the rubble of his civilization, dug up in 1849 from the ruins of Nineveh, ignored for a century and a half, and finally read correctly only after a Bristol astronomer ran the numbers through a computer his maker would have considered indistinguishable from a god. The scribe ends his record with a passage that has been mistranslated for over a century, usually as a religious blessing. Dr. Avi Loeb at Harvard, working through the cuneiform in its astronomical context, reads it differently. The closing lines, in the scribe's own voice. The stranger came from the darkness beyond the wanderers. It walked among us briefly before returning to fire. The priests say it was a warning. The wise say it was chance. I say only this: the heavens are not empty, and the night sky keeps many secrets. The night sky keeps many secrets, not kept, not in the past tense. The cuneiform construction is ongoing, present, active. He is not telling us about something that ended. He is telling us about something that is still happening, 4,000 years after he laid down his stylus, on a night when he had taken the measurement 3 times, because he could not believe his own eyes. If you have a theory about what the stranger moon really was, drop it in the comments. Captured asteroid, fragment of an older world, something we have not named yet. I read every comment, and the best ones shape the next video. Subscribe before you go, because next week I am breaking down the Denisova cave paintings that show animals that should not exist in Siberia. The video on screen is another astronomical event the ancients recorded that modern science is just now confirming. Click it